percentage composition. The percentage composition. The percentage of mass of an element in a compound is called percentage composition. किसी कंपाउंड में एलिमेंट का कितना परसेंट है बाय मास, ठीक है, तो उसी को हम क्या कहते हैं, परसेंटेज कंपोजिशन. एक एग्जांपल, फाइंड परसेंटेज कंपोजिशन ऑफ कॉन्स्टिट्यूएंट एलिमेंट्स ऑफ पोटेशियम डाइक्रोमेट. फार्मूला पोटेशियम डाइक्रोमेट is K2Cr2O7. atomic mass sometimes they have given, sometimes not given, so you have to remember K is equal to 39, chromium 52, oxygen 16. How we are finding percentage composition? Firstly, find molecular mass. Molecular mass of K2Cr2O7. Here three elements K, Cr and O. So you have to find percentage composition of K, Cr and O. Cr. 2 atom of K, the 2 into 39 plus 2 into 52 and 7 into 60. Solve it. 78, 104, add it, it will come 294. Molecular mass of potassium chromate will be 294. So find the composition of K. Percentage composition of potassium K. Mass of potassium divided by total mass, molecular mass, into 100. What will be the mass? Mass of potassium is 78 divided by 294 into 100. Solve this, it comes about 26.53. What we have found it? The percentage composition in potassium chromate, percentage composition of potassium is 26.53%. Same way, if you want to find the percentage composition of chromium, percentage of Cr in K2Cr2O7. Same way, mass of Cr present in potassium chromate, potassium dichromate, and divided by molecular mass. Molecular mass of potassium dichromate multiplied by 100. Here mass of chromium, that is 104, divided by molecular mass is 294 multiplied by 100. Solve this, divide, it will come 35.37%. If you calculate the percentage of chromium in potassium dichromate, so that is 35.37. Same way, if you want to find the percentage of oxygen, percentage of oxygen in potassium dichromate solution, what happened? Mass of oxygen divided by molecular mass of K2Cr2O7 multiplied by 100. Here mass will be 112 divided by molecular mass 294 multiplied by 100. Solve it, you will get 38.10%. This will be the percentage composition of constituent elements of potassium dichromate. See here, empirical formula. The simplest ratio of atoms of the constituent elements in a molecule is called empirical formula of that compound. How many elements? What are the simple ratio elements present in the compound? We are making a formula by simplest ratio, that is called the empirical formula. ठीक है, यार सपोज करो इसे हम हाइड्रोजन और ऑक्सीजन की बात करें तो उनका सिंपल रेशियो क्या है एटम्स का, तो 2 एटम ऑफ हाइड्रोजन प्रेजेंट होते हैं, 1 ऑक्सीजन, तो उनका सिंपल एम्पिरिकल फार्मूला क्या होगा बेटा, H2O. ठीक है, 2 हाइड्रोजन एंड 1 ऑक्सीजन. तो द सिंपलेस्ट रेशियो ऑफ एटम्स of the constituent elements in a molecule is called empirical formula. And what is molecular formula? Molecular formula is the formula which indicates the actual number of atoms. Actual number of atoms of the constituent elements in a molecule. जो actual number of atoms present in the molecule होंगे, that is called, उन्हें हम क्या कहते हैं बेटा, molecular formula. ठीक है, जैसे हम फॉर माई एग्जाम्पल आपको कहूँ, ठीक है, इफ विल टॉक अबाउट द एथीन, अगर मैं एथीन की बात करूँ, ठीक है, तो इन एथीन इफ विल सी व्हाट विल बी द रेशियो, सिंपल रेशियो ऑफ कार्बन एंड हाइड्रोजन. कार्बन एंड हाइड्रोजन तो दे आर इन 1:2. 1 carbon, so there are 2 hydrogen. If we will go for the empirical formula, what happen? Empirical formula will be CH2. But what will be the molecular formula of ethene? The molecular formula is C2H4. Actual number of carbon, 2 carbon are present and 4 hydrogen are present, but simple ratio is 1:2. So this is empirical formula and this will be the molecular actual number of carbon and hydrogen present in that molecule. That is molecular formula. You can see here a simple relation is there. If we see C2H4, so this is twice of CH2, or you can say CH2 whole twice. So there is also a simple relation, multiple relation. Molecular formula is empirical formula, a simple whole number times molecular formula will be of the simple formula. So this is the relation between molecular formula and empirical formula. There should be a simple whole numbers 1, 2, 3, 4 like that, what I have told here. Okay. For in the case of ethene, what we have seen, CH2 simple, this is empirical formula, simple ratio 1:2. But when we will go for the molecular formula C2H4, so it is 2 times of empirical formula. So 2 is here simple whole numbers, that is R. If empirical formula, suppose any compound CmHnOp, and this R is the ratio of molecular formula to empirical formula, the molecular formula will be R times of R times of empirical formula. This can be written like that also. R you can raise here. R will be multiplied in the whole empirical formula. Okay. If percentage composition, suppose they have given, how we are finding the empirical formula or molecular formula? One question I am giving is substance on analysis. Give following percentage composition: carbon 52.2%, hydrogen 13%, oxygen they have given 34.8%. Calculate empirical formula. See here, how we will find empirical formula? Percentage composition they have given. So firstly we are finding the number of atoms and number of moles present in that formula by the help of percentage composition. How we can find it? Because mass is given, mass upon molecular mass, that will be the number of moles. So we are finding generally number of moles, and simplest ratio we can find. After that we will find empirical formula. So suppose in this question carbon they have given 52.2. How many moles are present of carbon here? Number of moles of carbon. So how many carbons? They have given 52.2%, and mass of carbon, molecular mass is 12. So 52.2 upon 12, that will be the carbon. Simply we can see 12 4s are 48, 4.35. This will come around. Same way, find number of moles of hydrogen. Probably percentage is 13 and molecular mass 1, so it will comes 13.0. Same way, if we go for the oxygen, number of moles of oxygen present in that compound. Moles of oxygen. What happened? Percentage of oxygen upon molecular mass of oxygen. Atomic mass of oxygen. So 34.8 upon 60. These are the number of moles of atoms of oxygen. Number of moles of atoms of carbon present in that compound we are finding. This will come nearby 16 2s are 32 to less than 2.2, nearby 2.18. Nearby we can take it 2.2. This also nearby take we 4.4. Here we can see number of moles of carbon atom present in that compound is 4.4. Hydrogen is 13. Oxygen is 2.2. Formulate the simple ratio of number of moles of atom of carbon, hydrogen and oxygen. That will be 4.4, 13.0, 2.2. If you are dividing by 2.2, it will come nearly nearly it will come 2:6:1. So this is the simple ratio of number of moles are present in that compound of C, H and O. What will be the empirical formula? Empirical formula of that substance will be how many carbons they are presenting? 2 carbons, hydrogen presenting 6, oxygen 1. This will be the empirical formula of the substance. You see, a very simple method. Firstly, we are finding how many moles of that atom present in the substance. Carbon we have seen. If you want to find number of moles, you have to divide mass upon atomic mass. That is come nearly 4.4 here, 13 here, 2.2. So what will be the simple ratio in mole? Number of atoms, mole of atoms. This we have seen 2:6:1. That will be the empirical formula is C2H6O. An organic compound containing oxygen, carbon, hydrogen and nitrogen containing 20% of carbon, 6.7% hydrogen and 46.67 nitrogen. Its molecular mass was found 60. Find the molecular formula. See that substance contain oxygen, carbon, hydrogen and nitrogen, but they have given only percentage carbon, hydrogen and nitrogen. The total percentage will be 100. So we can find the rest. What they have not given, oxygen they have not given. Firstly we have to find the percentage of oxygen. What will be the percentage of oxygen? So firstly, total percentage of, they have given which? Carbon, hydrogen and nitrogen. Carbon, hydrogen and nitrogen. So carbon they have given 20, this they have given 6.7 and here 46.67. Add this, suppose this I have taken 0, 7, 3, 7, 1 here and this is 7. What this had come 73.37. What will the percentage of oxygen? Percentage of oxygen will be percentage of oxygen. So 100 minus 73.37. This will be 26.63. I told you, find the number of moles present in that substance of their constituent. So we will start from one by one. Suppose I have taken firstly carbon. Number of moles of carbon atom. Mass 20% divided by atomic mass, that is 12. So you can see here 4 3s are 4 5s are 5 by 3, around 1.66. Same way, number of moles of hydrogen atom. what happened? 6.7 divided by 1, so that is 6.7. Number of moles of nitrogen atom, so that is 46.67 divided by atomic mass of nitrogen, so that will 14 3s are 46. So this will come 33. Same way, number of moles of oxygen atom, so that is 26.63 divided by 16. So if we divide 26.63 divided by 16, it will come around 1.66. So this we have found the number of moles of oxygen, carbon, hydrogen and nitrogen. What will be the simplest ratio? Simplest ratio of number of moles of carbon, hydrogen, nitrogen and oxygen. So that is 1.66, 6.7, 3.33, 1.66 divided by 1.66. We can see it. This comes 1, around it is 4, it is 2. So this will be the simplest ratio of carbon, hydrogen, nitrogen and oxygen. What will be the empirical formula? Empirical formula. So see here, one carbon present, hydrogen is 4, nitrogen is 2, oxygen is 1. This will be the formula, empirical formula. Here we can see the empirical formula of that substance is C1H4N2O. What will be the empirical mass? Empirical mass. So 1 into 12, 4 into 1, 2 into 14 plus 1 into 16. So 12 plus 4 plus 28 plus 16. 16 for 20 and 20. This comes 60. What is the ratio? Molecular formula to empirical formula, R. Ratio. We will see. What will be the ratio? R. Molecular mass divided by empirical mass. Molecular mass they have given 60 upon 60, so that will come 1. So what will be the molecular formula? Molecular formula R into empirical formula. Empirical formula R is 1, and empirical formula is C1H4N2O. Molecular formula that compounds CH4N2O. When we are not writing, it will come CH4N2O. So this is the molecular formula of that organic compound.